Hello, my name is Yudhira and my partner Nancy. Today we are going to talk about why the Tacoma Bridge collapsed.
A bridge is a quintessential civil structure. One of the examples is the Tacoma Narrow Bridge. The Tacoma Narrow Bridge is the historical name given to the twin suspension bridge that spanned the Tacoma Narrow Strait and was originally built in 1940. It collapsed just 4 months later due to elastic failure. Since then, this topic has become popular, with several case studies discussing the failure phenomenon of suspension cable bridge.
By 1940, the Tacoma Narrow Bridge opened the traffic between Tacoma, Washington, and the Kitsap Peninsula. At the time, it was the third longest suspension bridge in the world. Leon Mosaic designed the bridge to be the most flexible ever constructed. Engineers of the time believed that the design, even though it exceeded a ratio of length, depth, and width that had previously been standard, was completely safe. Following the collapse, it was revealed that the engineers had not properly considered the aerodynamic forces that were in play at the location during a period of strong winds. At the time of construction, such forces were not commonly taken into consideration by engineering designers.
On November 7, high winds buffeted the area and the bridge swayed considerably. The first failure came at about 11 a.m. when concrete dropped from the road surface. Just minutes later, a 600-foot section of the bridge broke free. By this time, the bridge was being tossed back and forth quickly. At one time, the elevation of the sidewalk on one side of the bridge was 28 feet above that of the sidewalk on the other side. Even though the bridge towers were made of strong structural carbon steel, the bridge proved no match for the violent movement and collapse.
After the construction of the Tacoma Bridge, it was found to dangerously buckle and sway along its length in the windy conditions. Even with the normal winds, the bridge was undulating noticeably, and despite the engineers worried as to the condition in the presence of high winds. Alarmed by this, many engineers started conducting experiments in a wine tunnel on the structural behavior of the bridge when subject to wind load.
A replacement bridge opened on October 14, 1950, after more than 2 years of construction. It is the fifth longest suspension bridge in the United States, 45th longer than the original. Construction of the new bridge took into account the lesson learned in the collapse of the Tacoma Narrow Bridge, as did that of all subsequent suspension bridges. Today, the remains of the bridge are still at the bottom of Puget Sound, where they form one of the largest man-made reefs in the world. The spot was placed on the National Register of Historic Places in order to protect it against salvagers.
Civil engineers play an important role in the planning, construction, and ongoing maintenance of our nation's bridges in order to support their function, safety, and integrity. The biggest reason in terms of structural damage, like the Tacoma Bridge, collapse is because of the imprecise calculation of the load that is not in accordance with the standard. A Tacoma Bridge collapsed after being hit by a stone. Civil engineers took what they could from this incident to improve the design, particularly how the air pockets created by this stone could disrupt gravity and friction in the bridges, allowing them to succumb under stress. Here are some ways civil engineers can combat environmental factors. Number 1, ensure that the design standards set of civil engineers are exceeded. Number 2, create custom and flexible fabrication so that certain bridges can withstand earthquakes and winds. Number 3, allow water or large debris to pass through the bridge, creating better resistance during flooding. And number 4, a strong supervision for the government is also crucial to prevent and corruption activity.
That's our presentation. Hopefully it can add insight to all of you. Thank you. Assalamualaikum warahmatullahi wabarakatuh.